So here's our first definition. An enlargement. That's when you take an object and you increase all the dimensions by a certain amount. The certain amount that you increase them by would be the scale factor. So for example, if the distance between the eyes on one of them was 1 centimeter, and then the distance between the eyes becomes 2 centimeters, we would say that this has been enlarged by a scale factor of 2, because it's double. If you started off with the original one being not a nice number, let's say you measured this to be 1.5 centimeters, and this one ended up being 6 centimeters, what's the scale factor now? 4 times bigger. How could you find a scale factor? Well, you could take 6 and divide it by 1.5 and find out that it's 4. So we would say that this has been enlarged by a scale factor of 4. Next definition, a reduction. Sometimes it's nice to make something smaller. So you decrease the scale factor of an object. So here, if the original one was, I don't know, 8 centimeters, and the new one was 5 centimeters, what's the scale factor? I made it so it wasn't nice numbers. You might need a calculator, or you might need to tell me how you would do it on a calculator. Well, if you do 8 divided by 5, you'll get a number bigger than 1, and that would be an enlargement. Here, 8 divided by, we would go 5 divided by 8. Okay? So sometimes we write a scale factor as a decimal. Sometimes we write a scale factor as a ratio. And this ratio says that, well, every 8 centimeters on the original is equal to 5 centimeters on the reduction, because that's what happened in this one. Now, so we could have, most of the math that we'll be doing, it'll be like nice numbers. Oh, it went from 3 to 1, so you're dividing by 3. But there could be times that you have things not as nice numbers. So this is our scale factor. The number or the constant that you multiply by to either make something bigger or make something smaller. So if your scale factor is a number bigger than 1, that means you're going to get an enlargement. And if your scale factor is something less than 1, that indicates that you're going to get a reduction. Okay. Draw an enlargement of the following object with a scale factor of 2. So, what we can do is we need to, scale factor of 2 means every measurement needs to get multiplied by 2. Can you see that this point right here is 3 away from the origin? The origin is a kind of an important point because that's where things sort of are measured from. Oh, they're not very dark, right? They're a little bit.
Well, they're also in the middle.
Oh, and then, yeah, okay. So the graph on yours, it looks like the photocopier had some fun and shifted things around a little bit. It's supposed to be perfectly on there. do you see that that green dot is 3 units away from the origin? If you doubled that, and I'll draw that in purple, doubling 3 units away would make it 6 units away. Same thing with this green dot at the top. It's 3 units away. Doubling that would make it 6 units away. 6 units away and 6 units away. Join those lines.
Was it -3, 0 on the other side as well?
Yes. Yeah, it just, sometimes what happens is and it's weird, sometimes the spacing looks good on my computer screen. Obviously, it worked for when I copied and pasted, but something, when the computer decides to send it to the printer, sometimes they don't speak the same language, and things get off just a little bit. So how can we, should we write something down beside this to help you remember how you did this? What did we do? We take the distance from the origin. I'm going to underline that in blue because that was our blue point. To a point. I'll underline that in green because that was all of our green points. I could have said double it, but I said times it by 2 because you times by whatever your scale factor is. So the distance was 3. I times it by 2. That means my new distance should be 6. And what this does is it creates all the dimensions to be double. Can you see that between 2 green dots, it's like 1, 2, 3 diagonal lines? And now when I look between 2 purple dots, 1, 2, 3, 4, 5, 6 diagonal lines. It's perfectly doubled. Do you know what is not perfectly doubled? The area. The area, just because you double the dimensions, doesn't mean you double the area. Take a regular square. That's 2 by 2. What's the area of the square? 4. Double the sides. What's the new area of that square? It's not 8. It's 16. So just because you double the sides does not mean you double the area, which is kind of interesting. Okay, this one too is supposed to match up perfectly. Okay, we draw our origin as well. We have our point here, 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 and here on our original graph. And the distance between the origin and those points is 3. To do a reduction with a scale factor of 1/3. Same idea, right? Take the distance between the origin, which is the blue point, and a point, any of your green points. And now what do we multiply by? 1/3. So if I multiply by 1/3, what's 1/3 of 3? 1. 1, 1, 1. This makes just a tiny little square in the middle. put it right in there if you like. You can go to the bath. We're going to do the arrow. We're going to do the enlargement of the arrow together. Okay? Because it's a little bit trickier. So what I have is I have my origin here. Whoops, I'll do that in blue just to be consistent. So one of the things that you can do to help you out even more is if you think of the coordinates. So that first green dot that I drew, can you see that the coordinate of that one is at -2 on the x and 1 on the y? If you tripled it, because we still want to do a scale factor of 3, you're going to triple both the x distance and the y distance. So if I triple -2, -1, -2 tripled will get me to 2, 4, -6. And 1 tripled will get me to 3. -6, 3 as my new point. I can do the same thing for -2, -1. That will end up being at -6, -3. So sometimes the distance isn't easy to count because those would be on diagonals. But if you take the points and triple the coordinates of the points, things become easier. Especially like if I look at some of these points. Let's look at this one right here. It's not at a great spot. Can you see that at that green point, the x coordinate is 1/2, and the y coordinate is -1? If you tripled those, 1/2 times 3 would be 3/2. Go to my purple line. 3/2 is the same as 1/2. 1, 2, 3. You get 1.5, 3. 1.5, -3. 3/2, -3. Maybe I'll move that. We haven't finished it yet. I have so far only done this point, and that point. I've only done 3 points. Now, this point down there, what's going to happen to it? What is its coordinates, that bottom point right there? I'll write them up here. It's still going to be at +1/2, comma, and I go down 1.5, so that'll be -1.5. Switching between fractions and decimals, you can choose whichever one you want to work with. I know, fractions are good morning, Monday morning stuff, right? Now, if you times those by 3, what's going to happen to 1/2? It's going to go 1.5, so it's going to line up with this one, 1.5. This by 1/2 is going to get you to -4.5. So that point will be at 1.5, -4.5. So far, we've got this part, this part, this part. I can enlarge it. I upped the difficulty on this arrow right away, didn't I? Should we do an easy point? This is an easy point. This point right there, 0, 2, 2, 0. The x coordinate is 2. The y coordinate is 0. Times that by 3, where is it going to go? 6, 0. Now I have to zoom out for a second here because my purple dot will be at 2, 4, 6, 0. Can you see, because it's symmetrical, you could do a little bit of cheating here? Because you know where these points are at the bottom, you know that this one's going to line up right there, and this one's going to line up right there. And we have perfectly enlarged it by a factor of 3. We're not going to do the half on this one just because I didn't give you enough space.
So on none of them we're doing half, or?
We can do the half on the next one. But we'll not do the half on the arrow. Okay, let's look at the next one. Okay, we've got our original points are here, 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 and here. And you want to triple them. Okay? I'll let you triple this one on your own. What happened on this one? You had written a 7 there.
Oh, right.
And then 13. But you had
I must have minused it.
yeah. You did the work right. That's why you got the half mark. But you just wrote.
Okay.
Oh, 7 equals that, so I didn't see it. Yeah, I see what you.
Makes sense? I was sort of like, oh, you wrote the plus 6 right over the 13, and then you subtracted. All right, quick check. How did you do? I'm pretty good at this. I'll label my points here. So you can check if you had your points, count them out, if you had them in the same spot. Mm-hmm. What makes it a little bit weird is you can't notice it as, like, I know what you're saying. Because in your head, when you saw the original one, did you think of a regular octagon where all the sides are the same length? But if you look on the original one, the length, and I'll highlight it here, this length between these ones is actually shorter than, I'll do it in red, this length right here. Not a lot, but a little bit. When we expand it, you really notice that that length is longer than the other one, which makes it feel like, oh, did I do something wrong? Your eyes didn't pick up on that small difference when it was smaller, and you really almost can't see it at all on the orange one when I cut everything in half. But when you enlarge it, you're like, ooh. Right? It's like you take a picture of yourself. If you zoom in on your nose, you all of a sudden go, oh, I look better from far away. Try the next two. Okay, you can sort of get an idea if you've done something right by the shape it looks like. If it looks like you've tripled it, if it looks funny, like that's not the same shape, then you know you've probably done something wrong. So this one, these are where the points should be. There should be a point there, a point there, and a point there. That's your shape tripled. And your shape cut in half should be a point here. Oh, man. Mine is off. Come on.
Wait, I'm really confused because like it's not lining up. Is there another button here? On Siri, look at the next one.
Okay. There we go. Let's see if my smart board is oriented better. Point there. Point there. Point there. This would be the cut in half. Yeah. For this next one with round corners, I would do the original points that are nice are here, 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 and here. I'd triple those. Do that in purple. 2, 4, 6. 1, 2, 3. 2, 4, 6. 1, 2, 3. And then try to draw my oval nicely through there. Okay? Same thing with cutting in half. What's that? You try to, well, you have to, the points still have to be in the right spots. I will be checking where the endpoints of that triangle are. You can't just go and just hope it's in the right spot, because then it won't work. Okay.
Probably shouldn't put that in the,
No.
that's done.
Although, did you bring a lunch?
That's not, that's not, bring a lunch. What was that pencil good? There you go. It is terrible, it's all gone wrong. What were you
Okay.
This is just fun.
Oh, I got to do one more line. Okay. So, our next job is to draw an enlargement by a scale factor of 2. And so what you do in this situation is you take your original picture, measure out some sort of square. So looking at your picture, it looks like each of these is about a half a centimeter. So you draw a grid using half centimeters as your measurements over top of the picture that you have. Then you make a new grid and you double your squares. So now each of those squares are 1 centimeter. Does it make sense that whatever is in this square of the small grid, you now have to draw in that square of the big grid? So what I know this is, so now all I have to do is sort of go, okay, I'm going to draw from here halfway to here halfway. That's all I draw in that square. Now this square, which I hit in green, will match up with that square in green. Does it look like we go about from here to here, and there's a bit of the eye in there? And maybe you want to just finish the whole eye up. We got some more of these.
Oh, on our page it's a little bit,
Oh, there's a, oh yeah, you guys have eyebrows. Mine didn't show up. I'll add. I can't see.
it's kind of hard to see where the origin is.
Well, you don't need, oh, the grid line's got, breathe. Once again, you can see the photocopier frustrations,
Yeah.
computer frustrations. That image got shifted. Okay, so I will draw mine. You have fun drawing yours. Oh, yeah, I'm pretty happy. So we just enlarged it by a factor of 2, and the strategy is if you draw a set of grid lines and draw your new grid lines double, now you're looking at just redrawing in every square what was there. And what you will get that way is your proportions will be really nice. You're just drawing little squares, okay? Next one. Can you reduce Homer down half the size? So again, maybe the original squares here were ½ centimeter. And then I made new squares that were 1/4 of a centimeter. Well, I'm going to start 1, 2, 3, 4, 1, 2, 3, 4. Go from here to here. My pen is too thick. This is art.
I mean, that one's not even that bad.
That's not that bad. That's nice. I mean, what is when there's hardly any room, it's hard, right?
It looks like Peppa Pig. I'm Peppa Pig.
Okay. So next we'll look at scale diagrams. A scale diagram, you're wanting to represent a real object with a scale, and you want to use a scale because sometimes it doesn't make sense to draw things out actual size. For example, a map. It would be really annoying if someone gave you what happened here? This is just, oh, these ones were like weirdly, okay, I'll just get rid of those. If someone gave you a map, an actual size map, it would be annoying because the map would be, you know, from here to Portage la Prairie, you'd have a map that's 100 kilometers long and 100 kilometers wide and would never fit in your car. It would take up way too much paper. And so we create a scale diagram. All right, so if you're drawing plans to build a doghouse, but you don't want your plans to be too big, you might use a scale diagram. So a scale factor of 1 to 10 means that 1 centimeter on your drawing is 10 centimeters in reality. So from this, we could find out that the scale factor is 1 divided by 10th. Your drawing will be a reduction. 1/10 of the actual size.
Is it always drawn and then actual?
Yeah. So, well, I don't know if it's all, like some places might have it written differently, but they might clarify beforehand.
So it's always the actual object divided by
Mm-hmm.
the drawing.
Man, this is a bad photocopy. Can you see what that actually says?
Does anyone know what that says on the map?
20 kilometers by 7 meters, or 50 kilometers?
I'm going to see if I can zoom into it better for you guys. Okay, what I would like you to do, what we're going to actually do here is take out a ruler, and if you need to grab a ruler, you can grab one from Mr. Shirk.
Attack me, vultures. Anybody else need ruler? Nothing happens for you.
So, if we put a dot in the middle of Winnipeg and a dot in the middle of Portage la Prairie, measure how far in centimeters it is on the map. And tell me what you get. There'll be a little bit different answers depending on where you made your dot in the middle of Winnipeg. 4.5 centimeters?
Yeah.
About? Okay. And then I want you to go to this little thing in the bottom and measure in centimeters how far it is from that line to that line. 1 centimeter?
When you do that, do you go right from the diagonal point when you're to the dot?
Like this one here to here? Yeah, I just did a straight line and doesn't follow the road exactly.
Yeah, like do you follow just from exactly here to here like that?
Yeah.
Or would you just go like this?
No, exactly the diagonal. So we have on that scale, if this is 1 centimeter, that means that 1 centimeter on the drawing is, can anybody read that scale? How far it is? Looks like it's 20 kilometers. 20 kilometers in reality. So that becomes our scale. 1 centimeter on our map that we have in front of us is 20 kilometers in reality. So describing it in words, so according to that scale, how far is it from Winnipeg to Portage la Prairie? Okay? So if 1 centimeter is 20 kilometers, 1 centimeter is 20 kilometers, we want to figure out what would 4.5 centimeters be in kilometers. And with a scale, what's happening on this side is you're multiplying by 4.5. So you would have to do the same thing on this side and multiply by 4.5, and you get 90 kilometers.
I remember Mr. Lindsay, this is where he did so much on proportions of the bits.
Like crazy.
But too long.
Too much? Okay.